Example 2, we have 3x to the power 2n divided by n, and we're going to apply the ratio test. So I'm going to put the n plus 1 term in the numerator, but I'm going to flip it around here. So I have the 3x to the 2n, so n plus 1 times 2 is going to be 2n plus 2, and that n that goes with it, I'm just going to put down here as n plus 1. Okay, so what I'm doing is I'm color coding the n's in red and the power series in blue. So then the 3x to the power 2n, so that's the n term, and it's going to be over n, which becomes n in the numerator. Okay, so I've got my ratio test here. It's got to be less than 1. When I apply my limit, I'm going to simplify first. I'm going to group these terms. So I end up with n over n plus 1. Okay, that's the limit of that's going to be 1. And the 3x terms, the 2n powers cancel out. So I end up with 3x all squared. And that's less than 1. So when I apply the limit, I end up with 1 times, and I'm going to write this as 9x squared and that's less than 1. So I end up with x squared less than 1 over 9. And then solving for x, we're going to square root both sides here. And I get x squared, or x is less than or equal to 1 over 3. And so my interval, my radius of convergence is going to be 1/3. And at this point I have bigger than negative 1/3 and less than positive 1/3. Okay, so then I'm going to test my endpoints. So testing my endpoint of negative 1/3. Okay, so we're going to test x equals negative 1 over 3. And when I put it into the original series, I'm going to end up with negative 1 to the 2n, and that's all over n. And the limit as that goes to infinity. Well, this is the same, since that's an even power, that's equivalent to n equals 0 to infinity of 1 over n. So this is a harmonic series. This is divergent. So we do not include that negative 1/3 as part of the endpoint. So that's just going to end up being greater than, not equal to 1/3. Then we test the other endpoint. Okay, so we test x equals positive 1/3. So we get the series. And positive 1/3 gives us 1 to the power 2n over n. Again, this is our harmonic series. That 2n just becomes 1 over n. Okay, the 2n power doesn't really make a difference on 1. So again, this is harmonic. Therefore, divergent. Okay, and that endpoint is also an open endpoint. So my interval is going to be from negative 1 over 3, open, to positive 1 over 3, and both endpoints are open endpoints.